Welcome to the ITFreeTraining video on configuring NIC Teaming in Windows Server 2012 R2. This video will look at combining three network adapters together for redundancy and performance reasons at the hardware and software level. I will now change to my computer running Windows Server 2012 R2 to look at how to configure NIC Teaming. To start with, I will open Server Manager and then select the local server. On the Properties screen for the server, notice that there are three physical network adapters that have been installed on this server. Notice that the first adapter has been configured with an IP address. The other network adapters have been configured to use DHCP. If I select the first network adapter, this will bring up a window with the current network connections available on this server. I will now right-click on the first network adapter and open the Properties. Notice in the properties for the adapter, all items have ticks next to them except for the multiplexer protocol. Notice that I can open the properties for the IP4 protocol and configure it like you would expect. If I exit out of here and go back to Server Manager, notice that NIC Teaming is currently listed as disabled. To configure it, all I need to do is click the word Disabled. To create a new NIC team, select Tasks, and then select the option New Team. The network adapters that can be added to the NIC team on the server will be listed. It is just a matter of ticking which network adapters you want to use. You can have up to 32 network adapters in one NIC team. To configure additional options, select Additional Properties. The top option is Teaming Mode, which defaults to switch independent. The other two modes, static teaming and LACP, require hardware support. Switch independent requires no special hardware to operate and thus is the easier one to configure and use. The next option down is load balancing mode. The first option in load balancing is address hash. This mode uses characteristics of the network stream, like IP address and port, to determine which network adapter to send the data through. The next option, Hyper-V port, is used with virtual machines. It keeps different virtual machines on different network adapters. The last option, Dynamic, is only available on Windows Server 2012 R2. I would recommend this option if available, as it combines the best features of the previous two modes together. It also has the ability to dynamically move network streams between network adapters to help distribute the load between the network cards. Notice that the last option I can select is Standby Network Adapter. In this case, I will select the third network adapter as a standby adapter and then press OK to create the NIC team. The NIC team does not take too long to create. Notice that on the right-hand side, I can see the status of the network cards. Since the NIC team is in the process of being created, notice that the status of the two adapters is shown as Faulted Connection Pending. It took about 30 seconds for the status on both network adapters to change to active and the third to standby. If I go back to the network connections, once I move this window, I will once again open the properties for the first network adapter. Notice this time that all the items have been unticked except for Microsoft Network Adapter Multiplexer Protocol. If I select the IP4 protocol, notice that the Properties button is grayed out and I'm not able to configure it. If I go back to Network Connections, notice that a new network adapter has been created. If I open the properties for this network adapter, I can select IP4 and configure the network adapter with a valid IP address, subnet mask, gateway, and DNS server. If you want to configure the NIC team, it needs to be done through this network adapter. If I now open a command prompt and ping the IP address of NYDC1, notice that I get a response back, indicating the networking is working. Let's have a closer look at what has happened. Let's consider the example in which a server has three independent network adapters. What has essentially happened is a fourth virtual network adapter has been created. The virtual network adapter communicates with the three physical network adapters. This is why the three physical network adapters can no longer be configured. All configuration needs to be performed on the new virtual network adapter. The virtual adapter is responsible for communicating with the other network adapters. The benefit of this is the administrator and software running on the server do not need to understand how the NIC team works or what network adapters are available. All they need to do is use the virtual network adapter just like a normal physical network adapter. As we can see, the ping command is getting responses back from the other server, so the networking is working. If I were to unplug the first network adapter, notice that the status on the network adapter has changed to faulted media disconnected. Also, the third network adapter has changed from standby to active. Notice also the ping command was not affected. The failover between the network cards was seamless. If I unplug the second network card, notice that network card is now reported as faulted. The third network card is still reported as active. The ping command is still getting responses back, and there was no loss of traffic when the network cards were unplugged. As long as one network card in the NIC team is working, the NIC team will continue to function. If I plug the network cables back into the network cards, notice that the network card status will change to connection pending. After about 10 to 20 seconds, that card will return back to active. The third network card will also change back to standby. If I now go back to the properties of the NIC team, I can change the name of the NIC team to static team. Once the changes have been made, if I now go back to the ping command, notice that there were some general failures from the ping command. The process of changing the name caused the virtual adapter to have to be recreated, and thus the process temporarily dropped the connection. It is important to remember that when making some changes to a NIC team, this may cause the network connection to become unavailable for a short amount of time. The next change that I will make is to change the teaming mode to static teaming. Static teaming requires hardware support on your network switch. That is, it needs support for the protocol 802.3AD. In the case of my network switch, it supports this protocol without the need for the switch to be configured. This may be the case with your network switch, so all you need to do is select the option. However, a lot of network switches on the market will require some configuration of the network switch in order to allow static teaming to be used. Notice that when static teaming is selected, the last option, standby adapter, is grayed out. Switch independent is the only teaming mode that supports the use of standby adapters. Once apply was pressed, it took about 30 seconds for Windows to negotiate with the switch and set up static teaming, so don't be surprised if the process does not happen straight away on your network. Once the process has completed, notice that all the network adapters are listed as active. If I now unplug the second and third network cards, once again, network traffic will be routed through the one active network card that is available. If I open the Network Connections window, notice that the two network adapters are listed here as disconnected. If you want to get any indication of the status of the network cards in your NIC team, you can always look in here to get this information. I will now plug the two network cards back in, and, given enough time, Windows will put these two cards back into the NIC team and start using them again. If I select the last teaming mode, LACP, notice that once selected, an error appears saying faulted LACP negotiation. The switch I am using does not support this teaming mode. If it did, once it is configured on the switch, it is just a matter of selecting the option in the list. Before I end this video, I'm going to do a quick recap of the main features of NIC teaming. To understand NIC teaming, it is easiest to break it down to incoming and outgoing traffic. For incoming traffic, if you are using switch independent, incoming traffic will arrive via the same network card regardless of how many network cards are in the NIC team. The only exception to this is if you are using virtual machines. Since each virtual machine has a different MAC address, Windows can use this to link a virtual machine to a particular network card. In order for this to occur, the teaming mode needs to be Hyper-V port or dynamic. Switch independent is also the only teaming mode that supports standby adapters. In order to load balance the traffic coming into the server, you need to use static teaming or LACP. This requires your network switch to have hardware support. The incoming traffic is controlled by the switch, so its effectiveness at load balancing incoming traffic is based on the switch and the algorithms that it uses. Windows has no control over this. For outgoing traffic, Windows does have control over this. This is controlled by the load balancing mode. Regardless of whether you use a software or hardware-based teaming mode, the outbound traffic is determined by the setting load balancing mode. So essentially this means regardless of whether you use a software or hardware solution, you will get the same results for outgoing traffic. Address hash divides traffic based on the IP address and port used in the connection. Hyper-V port divides traffic based on the virtual machine that the traffic came from. Dynamic includes the features of the other two balancing modes. For this reason, it is recommended to use this mode. It also has the ability to move a network stream between network cards to attempt to balance network traffic. However, it is only available on Windows Server 2012 R2. It should be remembered that Windows does not balance outgoing network traffic at the packet level. For this reason, if one network stream has a large amount of data compared to the others, it will always be routed via the one network card, and thus the other network cards in the NIC team will be underutilized. That covers it for NIC teaming in Windows Server 2012 R2. If you liked this video, feel free to give us a thumbs up, as that helps us a lot. Thanks for watching, and I hope to see you in the other free videos from us.